Hello, everyone. Welcome to today's webinar, Training Models and Those Who Write Them, How Red Hat Training Fits into the AI ML Landscape, presented by Solutions Architect at Red Hat, Wes Urquhart. My name is Mariela Salinas, and I'll be assisting in moderating our session today. We are in Zoom for today's webinar, and we will be sharing a copy of this recording with all of you in an email after the session. We do encourage participation throughout the webinar, so please use the chat or that Q&A option for our short Q&A after the presentation. Educate 360 is so excited to present this webinar today. So without further ado, I'll hand it over to you, Wes.
Awesome. Thanks, Mariela. Appreciate it. Hey, everyone. My name is Wes Urquhart, as Mariela said. I'm an architect in the North America training and certification team at Red Hat. Really excited to be with you all today to talk about everyone's favorite topic, artificial intelligence. So training models and those who train them. I did make a last-minute tweak to the title there, so my fault on that, Mariela. But we're going to talk a bit about how Red Hat plays into this overall space and a little bit of background and context about the space in general. So just a brief overview of kind of the ground we're going to cover over the next hour or so. We'll kind of set the stage for what we're doing here, what we hope to cover, what we seek to kind of discuss today, what we maybe are not seeking to discuss today. We'll cover a brief explainer of AI/ML, and I do mean brief in this context because there are hours and hours and hours and hours and days you can go if you want to learn really in depth, but we'll kind of give a high level overview for the purposes of this conversation. Then we'll talk about Red Hat's approach and where we fit into that landscape. And then, of course, we'll fold in training into the picture of where Red Hat's training portfolio can kind of help you get started. We'll wrap and review, and then, as Mariela said, we'll close with some open discussion. Please feel free to add any comments or questions in the chat or in the Q&A. I will absolutely be checking it throughout the presentation. So please feel free to engage with us there. Want to make this interactive and as helpful for as many folks as possible throughout the presentation. Of course, if I don't get to your question kind of throughout the presentation here, I'm happy to kind of check in at the end and we can kind of round out. We should have 10-ish minutes or so for Q&A at the end of the presentation if it kind of goes as it usually does. So with that being said, let's advance to the why are we here portion. So you're probably hearing a lot about artificial intelligence and machine learning in the world right now, both in the news, in the media, on social media, just in your own fun free time. So what in the world are artificial intelligence and machine learning? We'll cover a brief and very high-level overview of those two concepts and how they fit together. We'll talk about where Red Hat fits into this overall landscape, understand where our technology and products sort of seek to compete and where we kind of set ourselves apart, and then how you can learn more with Red Hat training. One other disclaimer kind of ahead of this is you may have attended a webinar or a session or maybe even just watched a YouTube video or read some documentation as it relates to Red Hat and AI over the last 12 months. And this may sound different. And so why is that different? Why is this a different presentation? Well, Red Hat's approach, much like the AI landscape, is constantly evolving. Things change from day to day with artificial intelligence, sometimes from minute to minute. And so we are ready to make those changes kind of in step with the marketplace and with what's necessary and what our customers are needing. So in that context and in that vein, these presentations are going to be updated very, very frequently. You may hear something about where we are now. It may be different where we are in a couple of months. In fact, I know we have some fun announcements coming up at Red Hat Summit that will alter the picture slightly. So keep that in mind as well. So, keep that in mind as you sort of work through. Just because you saw a presentation on where Red Hat fits into the AI landscape maybe 6 months ago doesn't mean that it's going to be the same today as it will be in 6 months from now. So how do we know you have the latest information? I'm keeping my ear to the ground. I'm working with our folks in the AI BU. I'm making sure I'm keeping up to date on all of our latest technology and strategy where I can. These things do change a bit, so forgive me if there's something in here that is out of date tomorrow. But rest assured that as of recording today on March 26, 2025, this is as up to date as it's going to get. So without further ado, let's actually dig into the material here. So I'm gonna check the chat real quick just to see. Again, please feel free to ask questions in the chat. I don't see anything right now, so we'll keep on trucking. So what is this AI/ML I keep hearing about? A brief warning down there. This will almost certainly be an oversimplified set of explanations. Seek additional resources if you want more technical, nuanced explanations. It certainly will be. I shouldn't have even said almost there. It's going to be a very high-level understanding, and it'll be a point of view on it. There are multiple points of view on these topics. So keep that in mind as we kind of work our way through. All right, let's start with AI. Let's start with that piece, the first part, artificial intelligence. What is artificial intelligence for the purposes of this conversation? Well, you'll notice the umbrella icon there. I like to call AI an umbrella term, which means it encompasses a lot of different fields and technologies, a lot of different disciplines, a lot of different things that we interact with on a day-to-day basis and that are on the bleeding edge as well can be considered forms of artificial intelligence. The most generic possible way I've kind of come to define it is any computer that exhibits human-like intelligence and thought. Notice the human-like intelligence and thought there, not necessarily human. There's a lot of conversation around spirit, around true human nature within artificial intelligence and where that is and where that line is. We're going to park that for the purposes of this conversation. We're not really going to get into kind of those sorts of theories and those sorts of pieces. That's kind of not what we're here to do. So I will park that and let those smarter than I have those very high level conversations. We're going to focus more on the technology. One thing to note about that technology is it's been around in some form or fashion for decades, right? A lot of things that we consider day-to-day technologies that we lean on as predictive artificial intelligence has been around for a really long time. And things like forecasting and things like forecasting for weather, things like forecasting for finance. Those sorts of things have been around for a long time, and they kind of break themselves down into different buckets. Often it's predictive versus generative. A lot of the hype cycle that we're hearing about right now is about generative AI, but that doesn't mean predictive isn't still important. The lion's share of use cases that we still see in the world are predictive in large part. Some terms under the AI umbrella, though, include search algorithms. The algorithm is listening to me, be that on TikTok, be that on YouTube, be that on Spotify, for that example, be that on Google. The algorithm is predicting your behavior based on past actions and based on various other inputs that it's sort of tracking you. It could be from your browser history or cache or whatever it might be. So search algorithms, a form of artificial intelligence that's been around for a long time. A form that's been around for an even longer time is rule-based systems. Just using a chatbot on a website where it's asking you, or a phone tree asking you, hey, press one for this, press two for this, press three for that. That's a rule-based system, right? That is not human intelligence, but we've coded a tool to automatically direct traffic and direct your line of questioning into a certain bucket. That's a rules-based system. That's a form of artificial intelligence. It's been around for a really long time. And then, of course, there is machine learning, which is a much more robust discipline. And we're going to cover that off in a separate slide here in just a second. But the important thing to note here is that artificial intelligence is a very large field that encompasses a lot of different disciplines. Machine learning will always be some form of artificial intelligence, but artificial intelligence does not have to be a discipline of machine learning. So when you see AI ML put together all of the time, it's kind of because it's a subset when you see that slash AI, artificial intelligence, and within AI, it's machine learning. So we're going to talk a bit more in depth about machine learning here as we kind of move along. But some food for thought, if you want to interact with us here today, can you name some examples of where you see flavors of AI in your day-to-day life? Feel free to drop that in the chat. Oops, sorry, I'm on one screen here today, so I was trying to get the chat pulled up. Feel free to drop in the chat anything you see, as artificial intelligence that you interact with on a day-to-day basis. One that I will throw out there that I think is getting incredibly accurate, almost to the point of being unsettling, is mapping technology, where I'll be getting in my car with my wife to go to dinner, and my Apple Maps app will give me directions based on my past behaviors, and it knows where it thinks I'm going, down to the fact that we may not go there every week. We're not that much of a creature of habit, but it knows, hey, on every third Tuesday, it seems like you like to go to this sushi restaurant. So we're going to suggest that that's the directions you're going to. And it's correct more often than not. That's an example of artificial intelligence that I see in my day-to-day life very frequently. I think I saw something in the chat. And again, apologies for the slide moving here. Yeah, Copilot as well. That is definitely a much more bleeding edge addition of AI that more falls into the machine learning space and the generative AI space, where Copilot is helping you do things like build slide decks, for example, or do things in spreadsheets. That's much more bleeding edge, and we'll kind of actually use that as a lovely segue to talk about the machine learning portions here. So again, machine learning falling under the artificial intelligence umbrella. And machine learning as a discipline is the best way I've kind of come to explaining it is teaching a computer to respond to queries of all kinds by training it, quote, on huge volumes of sample data to the point where it, quote, learns how it should respond to those queries. So if you think about a machine learning process, kind of a workflow in its most basic form. You have a base model. A base model is, you can think of some of these that are out there. We're going to talk later today about the Granite family of models, which is the open source a series of models from IBM and Red Hat. There's also Mistral models. There's OpenAI, for example, which is like GPTO or whatever those models are called. I use our own at this phase of the game, so I'm not as familiar with those. But Llama 2, those sorts of models that big companies have developed, train them on a lot of very general sets of data to make them pretty good at answering really general queries. Or if it's a specific model, very specific queries. So it's very good at chat, or it's very good at generating images, or it's very good at generating slides or text, something of that nature. It's at its base. It's a generalist model at that point in time. Then what we're going to do is we're going to feed that model lots of data at this point to do a specific task. So in this case, let's talk about Amazon orders from thousands of people. So we're going to feed a model with a lot of Amazon orders so that we can sort of see, oh, this is what people are ordering. And this is maybe down the line what the same person has ordered, 6 months later or 3 weeks later, or these are commonly paired items together. We're just going to feed lots of data. And then we're going to grade the results. We're going to talk about different forms of this process in just a second. There are a few different ways to tackle it, but in some element, you're going to say, yep, you got your reading on that right. You assessed this and said, you saw data A and you gave output B. That's correct. Or no, that's incorrect. You probably want to go back and kind of use different parameters, different things to think about in order to kind of make an assessment and make a different judgment. And then the model learns. Right? The model learns from that behavior what is good and what is bad. And then we do it again. And the model learns more. And the model learns more. The theory here, and what you're kind of seeing is the more you do this and the more you give it cracks at this cycle, the better it's going to get. And I don't know about you all, but I think a lot of these tools that we see in our day-to-day lives, things like Amazon suggesting what item I should be buying, or when it's time for me to buy and re-up on something else, or my Maps app thinking exactly where I need to go, or Spotify recommending a playlist that I think is really good. These tools were not always this good for folks that have been using, that technology within their Maps apps or using Amazon for a long time. Those predictions haven't always been great. They've gotten a lot better over the last couple of years as more data has gone in, as they've gotten better at tuning it, as they've gotten better at parsing through very specific details with very fine-grained data. And it's impressive. And candidly, they're probably only going to get better. Now, there are cases where where you can overdo this and over-index it, and then suddenly you start to get some drift. That's a bit out of scope for the conversation today. That's really in depth. But suffice to say, generally speaking, more training on more data leads to better results. I'm going to check the chat here for any questions. Not seeing anything. Okay, we'll move right along. So a brief aside that I wanted to cover, I mentioned the training portion that we'd kind of separated out a little bit and dive into deeper detail. You will often hear training referred to as supervised or unsupervised in terms of that loop. The way you want to consider supervised versus unsupervised, supervised is a way you might think that makes a lot of sense. You get a bunch of training data and a junior data scientist goes in and labels it all and says, hey, we've got 6,000 bank alerts and 10% are marked as fraud and 90% are marked as legit transactions, right? So like a subset of 6,000 transactions, and we're going to subset and mark 10% as fraudulent. And we're going to distinguish that 10% is a different mix of why they're marked as fraudulent and why it should be seen that way. And we're going to make sure the model knows as we train it that it's looking at good data, it's looking at things that it should pass as okay, and things that it should flag as fraudulent. We're giving it that data ahead of time. We're kind of giving it the answer key and saying, look, this is how you should be learning. There's also unsupervised, where you just give it the 6,000 transactions and say, do your best to pick what is fraudulent and what is not fraudulent. There are advantages and disadvantages to both of these methods. If you have thoughts in the chat of what might be an advantage or a disadvantage of either of these methods, please feel free to pop it in. We'd love to hear what you think. As far as a couple just off the top here while we're waiting on folks, and I'm sorry if I take yours if you kind of go through this, but one is just the time it takes for a supervised data set to be curated. When you talk about data scientists and having to go through mountains of data to prepare it to make sure that the data going into the model is good and is ready to rock, This is some of what we're talking about here, literally going through line by line of all of these different transactions, making sure it's a clean set of data that is formatted in the correct way for ingestion by the model, and making sure we have flagged them in the appropriate ways such that we know the model is being trained on a data set that is highly controlled. An advantage you get out of that is something that is trained more to your specifications. It is tuned the way you want it to. It's looking out for the things that you've already told it are items that connote fraud. Unsupervised, an advantage is there's less time in prepping the data, right? But you're going to get some interesting results. And it might take longer and take more resources to do. Now, it doesn't necessarily mean the different results you'll get are bad. Sometimes a model can be creative in the way that it learns and make connections that the human mind doesn't always jump to. So that person preparing that data set may artificially kind of silo the model's thinking, whereas in an unsupervised structure, the model may start to make connections and things that we may not consider. That can be good or that can be bad. It just kind of depends. Either way, you need to grade it on the afterward and say, hey, this was a good result, this was a bad result, so that it knows and give it feedback. But it can take a lot longer and therefore be more resource intensive. However, both of these are highly resource intensive processes. And what I mean by resources is not just human time, but also computer capacity and resource capacity in terms of how much it takes to actually look through all this data, churn through it, make sense of it, and draw conclusions based off of it. So it can be quite a bit here. I was going to check the chat here to see if anyone had any thoughts. I don't see any thoughts in the chat, so we'll just keep on rolling. If you were typing away and you had some thoughts, feel free to pop them in and we can come back whenever that is there. So let's talk about what it means when we put them together in terms of AI ML. So after that brief aside on training. At the end of the day, interacting with artificial intelligence requires some form of application. For those of us that have used like either Microsoft Copilot or used ChatGPT or some other tool that is AI enabled, you're interacting with the front end, you're interacting with the screen, whether it's just a chat interface or it's maybe your Amazon page that has that prediction section for you or something of that nature. There's an application on top there, right? It's still just an application at the end of the day that is leveraging the information being passed to it from one of these, learning these trained models, right? But in this case, it's a lot of computing and it's a lot of data. Asking a question, for example, from ChatGPT, where it's asking it to draw on vast droves of knowledge and write an essay, takes a lot of computing. It takes a lot of resources to say, hey, write me an essay on, Queen XYZ the 10th from whatever country and do it in French, right? That takes a lot for it to draw on. And it can also be right or wrong. And so these sorts of things are resource intensive, but at the end of the day, you're still looking at applications and workloads running on some sort of infrastructure. So what that also means is you have a ton of different tools responsible for different parts of this cycle. And maybe I shouldn't say responsible, but that are involved in different portions of this cycle. Things like Starburst to help you with your data generation. Things like a base model, like I've got Mistral AI here, or you could have Granite in here as well, which we'll talk about in a minute. You've got maybe a pipeline tool to keep things tested and running. You've got Prometheus there to help you monitor things, to make sure everything is up to snuff, everything's running, you're getting results you want, workloads are up, you're not getting requests denied, those sorts of things. There's Python, because a lot of this is written in Python typically. PyTorch, Jupyter, and then, of course, VLM or VLLM, but a lot of folks call it VLM because LLM is hard to say, to help you, as an inference server, right? To help you actually interact with these, to kind of serve as that in between as part of the applications layer of inferencing, right? To kind of actually interact with the model underneath. These tools are great, but they're also disparate. They're their own things that have been developed in order to do a very specific thing within the data science pipeline, data science lifecycle. This can be tough to maintain if you're an IT shop that is maybe new to this or maybe has been in it for a while. But at the end of the day, a data scientist isn't necessarily an IT engineer that's looking to make sure that everything is compliant and make sure that everything is in secure ways, make sure all of my different versions of different applications integrate correctly so that everything is running correctly and it's up to snuff and my entire organization can have access to these AI tools whenever they need it. It can be very, very challenging. So where does Red Hat fit into this space? Well, if this story sounds familiar to you, it should, because It's a lot of the same story around Kubernetes and managing your container architecture, around understanding that your ecosystem is going to require more tools than just Kubernetes. There's an operating system, there's Kubernetes, and there's lots of tools to manage it. OpenShift helps you with creating a more streamlined package that's QA'd by Red Hat to make sure all of the different additions and tools and all of the different projects that ship with it all work together to give you one unified platform to run your container ecosystem. And then also your virtualized ecosystem too with OpenShift virtualization. That's a whole nother conversation. Well, that's for another day. But let's talk about where Red Hat fits into this space. So in enters the Red Hat AI platform, or Red Hat AI. For both generative AI and predictive AI, you've got the Red Hat AI platform that consists of Red Hat Enterprise Linux AI, so RHEL AI, and then OpenShift AI as well. We're going to talk in a lot more depth about both of these, but suffice to say that where OpenShift helps you with that ecosystem I talked about around containers or workloads around containers, OpenShift AI is an operator that's installed on top of OpenShift that gives you that suite of tools that helps you with that workload management on OpenShift for AI ML applications, right? And workloads. And then RHEL AI, similar story with more along the lines of developing models and developing applications. So we'll talk about that as well. Something to point out though is this also it seeks to be part of our open hybrid cloud methodology, where we want to be fairly agnostic. We want to let you run your AI tools wherever you want to, be it physical on a server under your desk, all the way out to the edge, in any cloud provider, with any hardware accelerator, whether it's NVIDIA, AMD, Intel, you name it. We want to be agnostic. We want to be there to run whatever you need to on whatever hardware landscape you need to, just like we are with OpenShift, just like we are with RHEL, just like we are with Ansible, just like we are with everything on our stack. So that's our goal. We may not be 100% there yet on every single aspect of every single tool because everything, like I mentioned at the very beginning, is very fast developing, but just know that's our goal. A bit more in depth on RHEL AI and OpenShift AI. I think I kind of talked to this a little bit. RHEL AI is going to give you that simplified approach to getting started. It's kind of that foundation platform where you can work on what would eventually be enterprise-ready applications on Linux with the Granite family of models from IBM, which we'll talk about in a second, with InstructLab to help you train those models in a very user-friendly way, which we'll talk about in a second, and other cool tools that ship with it. And then OpenShift AI is meant to help you scale those workloads with more capabilities for specifically AI applications than you would have with just a regular OpenShift deployment, for instance. And we'll talk more in depth about both of these in just a second. One thing to point out is OpenShift AI does include your RHEL AI entitlements too, so you don't necessarily have to be purchasing both. One other thing to point out before we kind of dive into the deep end of OpenShift AI and RHEL AI is the other piece to this. You've got models running with RHEL AI, you've got the AI platform with OpenShift AI. I don't want to forget or leave out a couple of other pieces here. One is the AI-enabled portfolio. You will start to see, in fact, you've already seen AI tools to help folks that are running, day-to-day operations within Ansible, for example, with Ansible Lightspeed to help you generate playbooks and generate automation with watsonx Code Assistant. You'll start to see similar things for RHEL and for OpenShift as well. We've announced certain things of that nature. They're in various stages of their lives, but bringing AI enablement, bringing AI tools to our products is something we want to do just as a course of action for what we want to do and be in the future. And then AI-enabled apps too. Something to point out, the Red Hat AI platform, or OpenShift AI and RHEL AI, isn't just there to run our tools, isn't just there to run our models. We want to be that point of that single point of truth for you for everything, right? So if you want to run a different model or your own workload, be it predictive or generative on OpenShift AI, we want to be there to help you do it. So we kind of want to be that single source of truth, that kind of one platform, one unified platform for you to be running all of your AI tools. Okay, check the chat here. No questions. Again, if you have questions, please feel free to ask in the chat. Happy to make this as interactive as possible. So keep that in mind as we go. All right, so let's put some of these other pieces into context. So you see this kind of scale graphic moving here, and I've talked a bit about scaling your workloads. So let's talk about it kind of step at a time. First, you've got InstructLab, and some folks may have heard of InstructLab before. We're going to talk a lot more in depth about it here in just a second. But step one is, like with a lot of Red Hat technologies, if you want to go and experiment with what we have out there just locally on your laptop, given that we are an open source company with our products, so are our AI products. They're truly open source. Others claim it, we are it, right? Our tooling is open source. It is community driven with us. It is kind of at the backing of it, and IBM at the backing of it to help really stand it all up and give that infrastructure. But it's open source. It's out there on GitHub for you to go take a look at. So you could go and play on your laptop, and we're going to talk about it today. You can play with things like InstructLab, things like Podman Desktop AI Lab. Go play with these models. Go play with these chat tools, with these things you can do today, completely free to try things. Right? You can try things out at a one laptop, one machine scale, even without a GPU, and have some success at just getting your hands on the tools and seeing if your idea, if your thought of, hey, I think there's a way to make an AI tool to make this easier for my team, to make analyzing this data easier for my team, or to draw more conclusions from this anecdotal data set, or to answer questions from this set of policy documents. I have a theory that we could do it. Well, step one is go play with it. And we'll talk about how to do that in just a minute. Step two is, okay, now let's talk about what it would take to make that production grade, right? We're not scaling yet. We're not giving the entire company access to it to go play with. But let's see if we can make this something that's more production grade from a security point of view, from a compliance point of view, from a resourcing point of view. We want to optimize it, but we want to make sure it works. We want to make sure you're not waiting 30 minutes for a request to complete on your lone CPU. We want to make sure that we're using kind of a centralized point where everyone's pulling from that same GPU bank. We want to make sure that we have some testing around it, right, with teacher and critic models. So in enter RHEL AI, where we say, okay, you've done some basic stuff on your own. Now let's really put it to the test. Let's scrutinize it some. Let's make it hardened. Let's make it work. And now let's talk about scaling that. All right, we're really happy with the proof of concept we've got going on right now with our application, our tool that we think will really help our business need with RHEL AI. Let's scale it out using OpenShift AI. Let's take that and make it available for the rest of our organization, the rest of the folks that want to use it. And let's do it in a very modern way. Let's do it in a way where folks have access when they need it, and we aren't wasting resources when people aren't using it. Let's scale with demand. Let's use our various tools available to us to help us make sure that we're testing new deployments appropriately. Let's make sure that we're monitoring it to monitor things like model drift and model bias. Let's make sure that we're monitoring security considerations with things like advanced cluster security. Let's make this a robust tool, just like we would for any of our other tools that we're running within our organization for us or for our customers. And enter OpenShift AI. So you can go from laptop to server or VM to cluster. That's the idea here. I'm going to check for questions here in the chat. Give me 1 second here. I'm moving the screen. The chat's not coming up. Okay. I haven't seen any banners come up, so I don't think any chat. So let's actually dig into the weeds a bit here of a few different aspects of the portfolio. So let's talk about InstructLab first. I've mentioned before that InstructLab is a way to sort of bring the model training process to folks that may be less inclined as a data scientist. A good example, I'm not a data scientist. I was able to play with InstructLab and get something up and running relatively easily with this tooling that was analyzing some of our data in the training organization, all locally. It's pretty cool stuff. So let's kind of explain InstructLab using an analogy. So if you're looking at a new hobby and you decide that baking is something you really want to get into, you love those fancy loaves of bread you get at the French bakery down the street, and you really can't get enough of them, but you're tired of spending your money on loaves at the bakery when you know you could try to do it yourself. And also just the artistry of it seems like something that could be fun to do. And you want to see if you can make results that compare to what they've got going on in those fancy French bakeries. Well, you can get it done your way. You may not have the fancy bread oven that has the pizza stone bottom with the steam release at fancy timings, but you've probably got an oven and you've probably got a Dutch oven, and you can put a pan of water in there, and at your scale, you can make something that approaches, if not exceeds, that bakery quality right at home. And part of that is modern tools that are available to you. Part of that is modern methodologies where folks have practiced at home and have gotten close and worked together kind of in a communal way, a community of folks working on processes together. And it's all out there for you to do. So you can do without a professional baking background. You don't have to go to kind of advanced degree for it. You don't have to have these really expensive sets of tools that are really high barrier to entry. You don't need those fancy ovens. You can do this at your scale at home using much more approachable methods and affordable tools. We can apply this model to model training, data scientists, and hobbyist developers. Let's check it out. So enter AI as an intimidating world. Building a model and then training it for the longest time has been something that is left to the realm of data scientists, which are excellent and they are very well trained, they are very well studied, and we need them from a research point of view. But the barrier to entry has been really high. You need to know some form of coding language, you need to understand some understanding of data science from a statistical lens and point of view, understand what you're seeing on plot charts, understand how to use very complex tools to see how your data is being trained. And it gets really tricky. And by the way, that's before we even talk about preparing the data and getting access to the data and how to do those sorts of things. This can be challenging. What if I'm somebody who's a hobbyist? I'm into AI, I'm into the idea. I'm sitting as an architect, for example, in my team, but I have an idea of something where I think we can get a problem solved with AI. Can I train a model myself? I can't. InstructLab is here to help you as a hobbyist. It's like taking those methods that folks are using at home to replicate what's happening in those fancy French bakeries for AI. InstructLab uses a unique methodology called LAB, which is a large language alignment model for chatbots, I think, or something of that nature, where it uses a taxonomy-driven method to say, hey, base model, great. Let me take some data as a sample, maybe their policy documents, and then I'm going to write a file. And in that file, I'm going to take a couple of excerpts from that data, and then I'm going to create a couple of questions and answer pairings around that data and say, hey, maybe this chunk of context from my policy document talks about whether it's okay to expense, when it's okay to expense business travel tickets versus economy travel tickets. And I'm going to ask questions of, hey, is it okay for someone to expense business travel, business class tickets when flying less than 400 miles? And then I can write the answer based on this section of the policy document. No, it is not okay. Keep that going, write that out for a few different scenarios. And then all you have to do is use InstructLab to take a base model, pair it with that data set that you have, along with that file that you've written, run the InstructLab methodology against it to add it to the taxonomy and train it. And lo and behold, you've got yourself a model that is trained on your specific use case. Obviously, there's more nuances here and there's more you can do, but that's the general idea and the promise of InstructLab. That's what it's there to help you do. It's there to democratize not only artificial intelligence, but training artificial intelligence, training these large language models, making it such that folks in individual teams, in companies, in organizations, in institutions all across the world, bringing that ability and that capability to their fingertips in a way that they never have been before. It's really, really cool stuff. If you can't tell, I'm pretty passionate about it. I think it's really, really neat. I think it's a potential game changer for people that want to get into artificial intelligence but don't really know where to start. So let's talk about what base model you're using InstructLab to train, because you do need a basis. Well, why not Granite? Granite is the Granite family of models from IBM as well as from Red Hat. We kind of work together on them, and it's been rated a strong performer in the Forrester Wave for AI foundation models for language, of course. Something to note about them: one is they're open source. This is a big deal. These are open sourced large language models distributed under the Apache 2.0 license. Other companies claim to be open or may insinuate that they're open. They may or may not be. We are. We're as open as you can get when it comes to these large language models. There is a lot of data underpinning them, and it can be hard to actually go through and sift through every single thing that was used. These are really, really large elements. But as open source as you can get, that's what we're striving to be, and more open source all the time. Purpose built for business. You might hear our CEO at Red Hat, Matt Hicks, go on places like CNBC. You might see documentation from us or messaging that says, we believe in small models. We believe in small purpose-built models to execute a specific function. Well, what does that mean? Rather than have a one chatbot to rule them all that can answer every question you have around policy, around financial trends, around metrics, around various textbooks. We think it makes a lot more sense to have models that are trained on a very specific use case that serves a business function. Much like I said earlier, my policy document example, that is, I want to train a model to specifically understand how to read my policy documentation and answer questions about it. What that does is it makes the training process a lot less intense. It also makes running it a lot less intensive. Things are much more cost effective, and the results are much better for that single use that you have gotten it to do. So the Granite family of models is meant to be that kind of agile based model for you. Oh, and by the way, indemnification comes with it too. We stand by, indemnifying customers for IP claims using these models. If you use the Granite family, the Granite model as your base, there are some lines where that gets drawn. When you put your data in, for example, the indemnification does stop. But in terms of where it's starting from, we stand by that we'll indemnify you for any IP claims. So, InstructLab, Granite, and Linux are a dynamic open source trio, which is why we put them together as RHEL AI. There are some other tools within RHEL AI, things like PyTorch, Python libraries, those sorts of things that you need in order to run things like InstructLab or run various other AI tools. But for the most part, these are the three core current value props. You've got Linux, and then you've got Granite and InstructLab there as a part of RHEL AI to get you started in developing your use case and developing those AI applications for your use cases at your business. And you can do it whenever you'd like to, right? But we're not done. Keep an eye out for more awesome AI news in the coming months. Red Hat acquired a company called Neural Magic that's been doing some really, really exciting stuff in this space, specifically in the inferencing space, that we're working with them really closely. I've personally been to a presentation from the folks from Neural Magic, and they're really excited to be here. It comes through in the way they talk and in their passion. And keep an eye out over the next few months for some really cool announcements that really accelerate what we're doing with artificial intelligence in this space, specifically with Neural Magic Intel. Keep an eye out for that. That's all I can really say. I wish I could tell you more. A brief word on OpenShift AI, because we spent some time in terms of getting into the weeds of our, RHEL AI portion of our portfolio. Here's a graphic that kind of depicts what I was talking about earlier as it relates to where OpenShift AI fits into OpenShift in general. So the bottom portion here represents OpenShift as we all know it, our awesome platform where you've got OpenShift there, which is Kubernetes with a bunch of other great tools built with it. Things like Argo CD, things like Tekton, things like Prometheus, things like various other tools that you have to help make things work, more fluid as an ecosystem to manage your containers and manage your containerized workloads, and also virtualize now. It's a whole other conversation. But that's the OpenShift we know and love. And the OpenShift we know and love can run wherever you want it to, meaning on a physical server under your desk, on a virtualized server, on something like VMware, can run over in any cloud you'd like it to, and beyond onto the edge. One additional layer you're going to see here for AI purposes is these compute accelerators. And I think AMD is missing from this list. This is an older graphic. But compute accelerators do definitely help when you're talking about the AI use cases. And then bada bing, you've got OpenShift AI as an operator installed on top of OpenShift. An operator, for those of you that may not be familiar, is think of it like a plugin that you'd install to enrich functionality in something like Microsoft Office. An operator is a very similar idea with just kind of more beefed up. There's a lot more going on. And so OpenShift AI does install as an operator on top of OpenShift. So you need OpenShift to run OpenShift AI. But if you have OpenShift and you want to bring your AI workloads, either predictive or generative, under one roof, OpenShift AI is a great answer to that problem. And like I mentioned before, there are lots of tools in the AI ML landscape for managing, for training, for securing, for testing, those sorts of things as it relates to your AI ML applications. And what we seek to do with OpenShift AI is curate a selection of those tools that work together, that we test to make sure that they integrate well, making sure they're version specific, and we support them for you. So if you have problems, you can come to us and get help. So that's the idea behind OpenShift AI. And again, RHEL AI comes with that as well, where you could be running RHEL AI as, a container, RHEL AI as a containerized workload for any of your AI applications. I'm gonna check for questions here. Cool, nothing. This is another kind of layout, more of a workflow as it relates to artificial intelligence and machine learning and how folks may interact with OpenShift and OpenShift AI. What I want to point out here, less than the kind of the workflow inside the graphic, is the who that's outside the graphic. Typically, when it comes to Red Hat, we focused a lot on infrastructure engineers, folks that are administering Linux or OpenShift, and application developers where they want to run their workloads on top of our infrastructure, which you still have here. You still see an application developer. But two new personas that we really think can benefit from OpenShift AI are your data scientists and your machine learning engineers or your ML ops folks. Data scientists need tools to build models, to build application, to build their models, to train their models. And OpenShift AI uses a lot of tools they're already familiar with. You know, InstructLab is one way to train a model. There are a lot of others that are more in-depth. OpenShift AI ships with those in-depth tools. So data scientists can benefit from OpenShift AI and ML engineers, folks that are in charge of, deploying the models, monitoring those models, executing pipelines to make sure things are done in order. They also benefit because a lot of those tools are also built into OpenShift AI. Just to summarize here, the Red Hat AI platform is there to meet you for your enterprise AI needs with the best in open source. I just want to reiterate that we still are sticking with our open source ideology that is core to who we are, core to our heart at Red Hat as a part of the Red Hat AI portfolio. And again, we're building new features and new things into this all the time. So keep an eye out for new updates as it relates to our AI portfolio. We're building things as fast as we can. We're adding functionality. We're adding new use cases. So really, really exciting stuff to come. I'm really excited about where we are and where we're going as far as Red Hat and AI is concerned. So training, where does that fit into all the puzzle? So you want to get started. You want to learn about AI and you want to learn about Red Hat's tools. Awesome. Let's talk about how. Couple things. So with Red Hat training, you've got a variety of different options to learn, regardless of what material it is you're looking to train on, be it OpenShift AI, be it RHEL AI, be it just RHEL, or be it just OpenShift. We offer a variety of different ways to get enablement in your hands. Regardless of how you're taking our training, all of our training is a combination of lecture or textbooks or videos, however you choose to consume it, and hands-on keys. We really do believe that doing is learning. So you can expect roughly 50% of our material is going to be lecture and roughly 50% is going to be hands-on practical exercises that are there to help you take what you've learned in that class and execute it against practical scenarios so that you're ready to use that knowledge out in the real world. There are two buckets kind of you can think of our training as falling into: live with an instructor, and you can do that signing up for a class that we're running, and whoever else shows up with you can kind of log into that class and you're just taking it for that week. Or as a private class, if you want to have an instructor come to you all or do it over a virtual setting, we can do that too for just you and your team. We're seeing more and more folks gravitating back towards in-person for training to get teams together. It's a really great excuse to do some team building for teams that may have been hired remotely in a more disparate fashion. Any excuse to get everyone together these days is really useful. Private training is a really good way to do that. So if you want to kind of bring your team together, get trained for a few days, maybe do some other work as a team, do some mapping things out, maybe do some planning, training is a great way to kind of make that vehicle happen for you. We have instructors all over the world and we fly them to you, to your site to kind of make it work for you all. Or on your schedule as well. If you want to go self-paced, that's great. All of our courses are available, save one or two, in a self-paced format. Same great material that you get from an instructor with textbooks, with videos that are recorded in a studio for the self-paced learner. That's very important. We're not talking about back of the classroom footage taken in an accounting 101 course that you have to really hold your ear to the speaker to hear what the professor's saying so you can study for your final. We're talking about, classes that are recorded in a studio with the self-paced learner in mind for you, very professionally done, as well as access to the labs that are embedded in the courses. So you've got those labs alongside that you can spin up on demand at your own notice for courses. And then you're seeing there your RHLS Premium exclusive here, where it combines the best of both worlds. You've got your self-paced options there that we talked about in the learning subscription, along with a set schedule that is exclusive to the premium subscribers of RHLS that can take courses that are set up on a schedule for you. You can sign up. They're delivered in 3-hour increments by an instructor, and you can go sign up for courses in that regard as well. I did see a question in the chat, so I'm going to see if I can go grab it. How are secure when it, this is a great question. How secure are your platforms when it comes to privacy of data, i.e. healthcare HIPAA? This is a great question. So I'm going to assume you're not talking about RHLS, but you're talking about the Granite family of models and OpenShift AI and all that good stuff. So I want to go back to this graphic here. We'll take a pause on the training conversation. We'll get back to that in a second. I know you're all waiting for the courses, but um, this is one of the main value propositions of our tooling here. So for starters, our products are all incredibly secure. We do our best to comply with all security standards across the world, government security standards, whether it's a military security standard. We make sure our products are in compliance in those regards, and you have tools to monitor security concerns, whether it's something like SE Linux just embedded within Linux that's lived there forever, or something like an advanced cluster security to monitor various different security policies within OpenShift. Both of those exist along with a myriad of other security toolings to help you make sure your deployment is secure. As far as data is concerned, this is something I really want. I'm going to go backwards here. This is something I really want to kind of sit with for a second. Right now, if you were to go and use a model and you wanted to go use a third-party model and you wanted to put your own data in it, in some cases, you may be giving your data to that company. You may be giving your data to the owner of that company, and that may not be compliant, right? There's a reason why some of us have been warned, hey, don't do company work on AI tools that are outside of our company, because at that point, we don't know what you're giving away. Well, with the Red Hat AI portfolio, you can use the Granite family of models as a basis and then bring your own data in locally on your own servers, on your own hardware, or your own private cloud. You can bring in a Granite model as a point in time artifact that we indemnify from a legal point of view. And then you can, in a private way, in a private server, put your data into it and train against it without ever exposing it to a third party set of vendors. And you're not giving it over to us either at that point. It is all yours at that point in time, right? So you're not at that point releasing that data to anywhere else that you wouldn't be already releasing on your own servers internally. So just another way to sort of keep it secure. Exactly what you were getting at. Absolutely. Great question. Great. I'm glad you asked. It's a really great point. It's something I wish I would have brought up kind of on our own. So thank you very much for asking that question. It's a really great one. Okay. Back to the training. And if you have any other questions, please feel free to ask. That was a great one. So we talked about the ways to train. Let's talk about the courses themselves. So like I mentioned, this space is evolving very, very quickly. So a few things I want to point out. We've got a lot of different options for learning of various different portions of our AI portfolio. At the top here, something you'll notice as an RHLS exclusive are a couple of lessons. Our learning subscription now has unique tidbits of content that are time-boxed elements, maybe a couple of hours worth of learning that may not fit into one of our full formal training classes, but are pieces of knowledge that we thought were worth sharing with our customers. In-enter lessons in RHLS, and in-enter in this case, 2 separate AI lessons on Podman Desktop. Podman Desktop is a tool that you can install to run containers on Windows, on Mac, on Linux. Yes, I said Windows, in order to run containerized workloads from a graphical user interface. It's really, really neat. And what you can do within Podman Desktop 2 is install something called the AI Lab extension that gives you the ability to pretty much quick start, go grab a couple of models and run a quick chatbot without really knowing how to do much around those things and be playing with a model and experimenting with it, which is really, really neat. If we have time, we're actually going to get into a demo of one of these in a minute. Then in terms of more formal training, a couple of things. We have our technical overview portfolio, which is kind of this next thing, this Red Hat Enterprise Linux AI technical overview is one of those. These are a series of no-cost videos on training.redhat.com that guide you through the basics. No hands-on keys, just some videos that explain, hey, in this case, this is what RHEL AI is. This is how we fit into the overall landscape. And let me show you some other cool things as it relates to RHEL AI, maybe some demos. So nothing super crazy here, but a good foundation and a good next step if you want to kind of experiment with some free enablement. We have a course coming soon on RHEL AI. It's in process. I was just on a call today about it being developed. Develop, test, and run the Granite family of LLMs with Red Hat Enterprise Linux AI. So it's going to go into teaching you some of those core foundations that I talked about today with Granite and with InstructLab, and actually being able to train a model and tune a model on RHEL AI. So keep an eye out for that. It's coming soon. And then OpenShift AI. We have a technical overview. Again, free to anybody. A couple of hours of videos just explaining what OpenShift AI is. And then we have a course, Developing and Deploying AI/ML Applications on Red Hat OpenShift AI. Whew, that's a mouthful. It does what it sounds like. It gives an intro to OpenShift AI and what it is, how to administer it, keep the lights on, how do I deploy a model, how do I test that model, how do I put a pipeline to it to make sure that things are all running kind of in a more automated fashion. Those sorts of things you may want to understand if you're using OpenShift AI to kind of manage those workloads. And then there's the certification available as well. Okay, I'm looking at the clock. We've got about 10 minutes left. Let me see here. I don't see any questions in the chat. I think I have time to kind of do this briefly just to walk you through what a lesson will look like. We probably won't get through all of it, but there is one thing I want to make sure I show you. So let me share my screen here. I'm going to share the entire screen this time. Excellent. It's loading. Now it says it's paused. Resume, share, share. Well, the screen share is not cooperating with me, so maybe the demo will have to live. The demo gods have already stopped me before I can. The screen share is just stuck. Let me just try to stop the share and let me reshare. There we go. Okay, we got it now. Just had to reset. So this is our Red Hat Learning subscription. This is the homepage. So if I scroll down, you'll notice that I've got one of those lessons already in my progress bar queued up for running models locally with Podman Desktop AI Lab. That's one of those lessons that we just saw on the previous slide. I'm going to launch it. And if you look here at the overview, you see some objectives here about what we're looking to do with the entirety of the lesson, some audience information and then prerequisites. And if you come down here, you can see the outline of what all you're going to get into. I'm going to focus on this guided exercise for running models locally. Now, I will mention that there is a lab environment tab here and an option to spin up a lab within the learning subscription for you to go execute these. So you don't have to install anything on your own machine. I happen to have Podman AI Lab already installed on my Mac. And so for the purposes of this demo, it's a lot easier for me just to show it to you on my laptop, but you don't have to do that. You can open up a lab environment here and do it all virtually just through the web browser. So at this point, it's telling you, assume you're developing an application that includes a conversational assistant. To implement this assistant, you consider the use of a pre-trained open source LLM, in particular the Granite 7B model. I'm going to use 8B, but either way. This exercise guides you to run such a model in your workstation with Podman AI Lab. That's very descriptive, better than I could have done. So it wants you to open the Podman AI Lab application, and then it wants you to do some navigation to kind of show you what to look at here. So I actually already have this open. This is Podman Desktop. Again, this is a tool you can use to run containerized workloads right from your laptop without any real fuss, any extra weight on top of it. You can do a lot of really cool stuff with this. We're not going to go too deep into exploring it today. I just want to use it to show you some of the AI tools. So Podman AI Lab is this lovely little otter down here. It's the AI Lab extension. And what it does when it pulls up here for me, there it is. I'll go to the dashboard, is it gives you a really cool set of tools to get started and play with AI quickly. And it's completely free, by the way. I don't think I mentioned that yet. You can go download this today completely free. So it gives you, AI apps like a recipe catalog. So things you can do just to spin up a chatbot or to spin up a code generation bot or a RAG chatbot. If you just want to get playing with kind of pre-built capabilities on your local machine. You can also look at a catalog of models you can install. So I've already got, like I said, that Granite 3.18b installed here on my laptop, and then various services and playgrounds and other information. So it's pretty cool stuff. So in this exercise, what you do is you run through it, you open the catalog, you download a model. I've already downloaded it. And then once you wait, you can actually go see and interact with that model, creating a model service, and then you can play with it, both this way with kind of a more command line centric view, or it's taking a minute. It crashed on me. Let me see if I've got one running over here already. I do. So I've got a playground running here. So imagine through the magic of television, this was already here. And what you can actually do is you can log in and you can come and see, you can actually kind of interact and chat with an AI bot in this case that is just running an untrained edition of the Granite model. And you can see how it does. I want to show you a great example of model bias. So I happen to know that one of our great developers in our team at Red Hat is a big Tennessee Volunteer football fan. And I happen to know, based on this answer, when I ask about Tennessee football, that it gives a really robust and detailed response. I myself am a University of North Carolina Chapel Hill basketball fan, and I was curious if the model gave me similar data sets. So if I scroll down here, I can actually see that, oh, it got fixed. So what I will tell you is this is good. This means that the model is different. So this actually answered it in a pretty remarkable way. However, if I go back to my slide deck, I would show you that an astute North Carolina fan would know that when you look at the section here that is passionate fan base of the second one, it's a little small, but it's number 9 on the second. The University of North Carolina has one of the most passionate and dedicated fan bases in college basketball, known for their unwavering support. Oh, that's not it. Where is it? Where's the Cameron Crazy piece? There's a part. There it is. UNC plays their home games at Cameron Indoor Stadium, known for its raucous student section, the Cameron Crazies. Astute college basketball observers would know that is not the University of North Carolina. That is the arch rival, Duke, which is not okay. So I need to go back in and retrain the model to make sure it knows never to do this ever again. But that's an example of model bias, right? This is why we train models, because there's a base, and that base is only good at so many things. It's not going to know every single thing about every single subject. You have to go and actually do that work and train it against your data to answer the questions in the way that you need it to be answered to make sure it's right. And that's part of the evaluation process, right? You start with a base, you see what it can do, you realize it has its limitations, and then you go train it with tools like InstructLab, and then you iterate on that and you make it better and you keep making it better. That's that pipeline we talked about. So I'm going to wrap in review now. So after that brief demo, we've only got a couple minutes left. So just for the sake of time, I'm going to cut it there and happily review kind of what we talked about. Machine learning is a type of artificial intelligence that many are embracing for advanced application development. It is here. Machine learning and generative AI is kind of the real hot topic. It's really the driving force behind a lot of development right now in the technology space. Red Hat offers open source solutions for everyone in the AI journey, from data scientists to developers, all the way to operations teams. We're there for you with open source. We always have been, we always will be. And then Red Hat Training is ready to help customers learn these new and exciting technologies. So if you want to get started and get your hands on these technologies, go download them online, come engage with Red Hat Training, come get some formal knowledge on it, and then go off and use these tools to do great things at your own organizations, your own companies, or heck, just for yourself. And that's all I had today. I'm looking at the clock. We got about 3 minutes left for any Q&A. I know we had a couple of questions throughout, but if you have any additional questions, now is a great time just to pop them in the chat, and we're happy to answer those for you. But while we wait to see if anybody has any questions, Mariela, I don't know if you want to come on and say any closing words while we wait for anyone to ask any questions, but happy to turn it back over to you to kind of close us out a little bit here.
Absolutely, Wes. Yeah, I went ahead and dropped that link. And if you want any more info on this topic, please feel free to click on that or visit us at newhorizons.com. And just as a quick reminder, if anyone wasn't able to attend the entire session, you will absolutely be able to get a recording in your email after the webinar. So be on the lookout for that. All righty, I think that'll do it for us. We got a nice thank you for the great info. So thank you all so much for attending, and appreciate your engagement today. And thank you, Russ, for all this
Yeah,
great info. This is fantastic info, Wes.
Yeah, thank you very much. Thank you very much for having me. Thank you all. I hope this was very helpful. As Mariela said, feel free to check out that link. Feel free to watch the recording. And if you have questions, reach out to your New Horizons point of contact, your Red Hat point of contact, and we're happy to help kind of continue the conversation. So thank you for having me, and I hope everyone has a great day.
Awesome. Thanks for being here, Wes. And thanks everyone for joining us. Have a great rest of your day, and we'll see you all very soon. Bye for now.